So we are going to talk about building Calico policies, so just some best practices and how to build them, what to take in consideration. So Kubernetes network and challenges, you are probably familiar with that, so I'll be just quick into it. Security stratagems, implementing the policies and optimizing them. So I'll try to be quick on that because you're already familiar with that. So that's Kubernetes. You have a cluster with multiple nodes and they create a flat network. Everything is open between the pods. So if you have a pod on the node number 1, the blue, it can talk to the pods on the node, the purple node. Nothing very special here, it just everything is open. So it helps with the pods communications because everything can talk to everything. So it's kind of cool in terms of networking because you have nothing to consider in terms of routing or other protocols, but it's kind of a nest of security issues here. Automatic IP management, pretty self-explanatory. You create a pod, it has a new IP, it's assigned automatically. Service discovery, same thing, you create a service, it's backed up by pods. And to do scalability and simplify routing, same thing. If you scale up by like hundreds, you have nothing to do clearly. So Kubernetes is very cool for that, and that's why it's called an orchestrator basically. The problem with the Kubernetes network is you're going to face new challenges. So you may have multiple clusters in different regions, like AWS, Azure, and they also need to talk to your on-prem environment behind the firewall or some other web services like Salesforce. So the new challenges can be lateral movement of threats. Like I said, you know, the network is kind of open. So it means if you have a pod on node 1, it can talk to node 2. So if there is a breach somewhere, there is a malware, it can talk to the other pods. So it's kind of something you don't want. There is no zone-based architecture. In a, let's say, traditional environment, you will have zone-based architecture like DMZ, so you can create VLANs to separate everything. In Kubernetes, we don't have that. So you'll have the namespace, application, and multi-tenancy isolation. That will be one of your challenge. Compliances, if you work in EU, you want to be GDPR. If you sell some goods and you want to be PCI compliant, you'll have to ensure that those PCI pod talks only to PCI pods and not the other one. Multi-cluster can be a challenge too, and you'll have also, every control for like egress, firewall integrations, etc. So it's a lot of new challenges you'll face. So of course, new challenges means you need new skills, new knowledge, new tools. So that's why we're going to talk about Calico policies. So even before starting with policies, you need to have a plan. How are you going to create your policies and put them in place? So first of all, you have to define responsibilities because Kubernetes can be an application, it can be a platform, and also it will talk to the outside world. So you need to define your teams, like the security team will be in charge of what is talking from Kubernetes to the outside. You'll have the platform teams, they can be in charge of the common resources like a kube DNS, and you'll have your DevOps teams that will be doing the applications. So you have to specify who is in charge of what. And then we'll have the security policy authoring. Who is going to create the policies? Are you giving the rights to the security team to do only security policies? Or will you create a common team that will receive tickets from those teams? So that's the security policy authoring. In Calico, we have a notion of tiers. The tiers, it's for Calico Enterprise and Cloud. So in tiers, we can group policies and we can use some RBAC roles to enable people to create policies in those groups. So you can create a tier for security, for the platform, or the DevOps applications. So it means you can give the right to everybody to create policies, but they will have a certain zone where they can apply the policies. So for instance, if the security team says you cannot go to Google, an application team that will create a policy to reach Google won't work because the order will be way below, because the tier will be at a lower priority. Segmentation strategy. So if you want to apply micro-segmentations, namespace isolation, so you have to define that before. Your tenants as well. Maybe you want multiple tenants. And what's very important is you need an inventory of apps, namespaces, and everything that will be in your environment. Because if you don't know the apps and what they're doing, it will be impossible for you to create your policies, basic stuff, and develop a label standardization. Kubernetes works on label, so labels are very important. So we have this kind of funnel of scope of security, so we start very wide, and we narrow it to default deny. So you can see we have enterprise security controls, platform controls, multi-tenancy, micro-segmentation, and default deny. So that's how we're going to scope the responsibilities between teams. So one of the strategy we can use with Calico is the zero trust. So what's zero trust? You probably know it because it exists outside of Kubernetes. So all the connections that exist will be enforced. We have to identify all of the endpoints with multiple criteria. So in Kubernetes, it's pretty obvious we use namespaces and labels. We allow only what is needed, and the rest should be denied. Policy integrity, just like if a pod is compromised, it has a malware, it shouldn't be able to elevate its privileges. Encryption, recommended, not mandatory. So what do I mean by here? You can use a service mesh with the MTLS to secure everything, but it's kind of complex. It takes resources, and you need new skills. Or you can simply use some encryptions between nodes, and the pods that are on the same node, they can just talk to them freely. So that's what we do with Calico. We use WireGuard. You can just enable WireGuards in one click, and then your cluster is encrypted. So if a pod from one node talks to another pod on another node, it will be encrypted. And the organizational involvement. So that's more the political aspect of the thing. You have to include all the teams into the conversations. And generally, it's the security team that is difficult to deal with, but it's their job, to secure everything, so we cannot blame them. So zero trust looks like this in real life. You've got some pods, they can access a resource, and they don't access the other resource. It's pretty self-explanatory. And how does it look like in Calico? We have here the policies board of Calico Cloud or Calico Enterprise. And you can see we have at the top the application tier. So it's like the bottom tier with the lowest priority for my application developer, DevOps. And we have a policy per endpoint, and it allows a specific flow, just what they need for their to function properly, to work properly. So that's the zero trust with Calico. It's how we're going to build it. So now, the thing with zero trust is, in order to make it zero trust, we need to block everything. So we're going to use the default deny. And by using the default deny, we're going to create the namespace isolation. You maybe know it with like micro-segmentations or nano-segmentations, whatever the name, it's the way it is. So the pods are allowed to talk to everyone in the cluster. So zero trust will allow only what is needed for your application to work. So if pod A talks to pod B with the port 80, we allow that, we block the rest. If it doesn't talk to pod C on the same namespace, we block it anyway, because it's not needed, so why would you open it? The caveat with that is if a new pod is created in the namespace, this pod will have no policy, so it can talk to other pod in the same namespace. So it means you can still have some lateral movement. That's why you need the default deny to block everything that is not needed. So the solution, we implement a default deny policy post zero trust. If you heard earlier today, Reza was saying the tier with the orders. So the policy has an order in Calico. So you can name them like, label them like 1, 2, 3, 100, 1000. So you're going to allow all the connection with the high order, and then you're going to block everything at the very bottom. So the result is, if a new pod is created in your namespace, this pod will be completely isolated. It won't be able to talk to outside the namespace or to talk to other pod in the same namespace. So basically, if you have a malware or something in your application, you're safe. The application will still work, and there will be no impact whatsoever on the cluster. You'll just see some deny flows in your Calico service graph. So in order to build that, you've got two ways. The first one is a blank page, and you start from scratch. You build your YAML manifest. It's what people do. Or we can use the policy recommendations. So it's a feature we have with Calico Cloud and Enterprise, and what it does is, let's say you have a brand new cluster. You deploy your application. You let it run for some minutes, hours, days, whatever. And it's going to scan and see all the flows that exist between the pods. And it's going to tell you, this one is needed, this one is needed. It creates the policy per microservice. It's in stage mode, so it's kind of a policy that doesn't enforce the rules. It just monitors them, so you can review if it works or not without breaking the cluster. So it's even perfect for the production. If you need to change something in production, you've got your safety net. And when you're happy with the policy, you can edit them, check out the rules, and just enforce them. So it's going to build everything for you.
This one is only available on the Calico.
Indeed, yeah. Calico Cloud for the SaaS and Calico Enterprise if you want to install it on-prem. So it's a nice feature because if you start from a blank page, you can already have everything in place. And you don't even need to know exactly what the application does, and it looks at the flows for you. So now, what are the benefits of using Calico policies? So first of all, we said it earlier, we use the full Kubernetes policy features, and we're going to enrich it with some new additional kinds, if I call it. So for instance, we have the global network policies. Let's say you want to allow traffic from all your pods to the kubedns. So kubedns, it's a platform feature. It's a platform service, so it is needed for everything. So what you can do is just build a global network policy. You don't need any namespace. So it's, I just highlighted it in global network policy, and then you can see it's allow UDP 53 kubedns. And because it's a platform policy, you put it in a platform tier, which is higher than your applications. So it means it's open for all the applications. Ability to protect host and VMs. Something interesting, you can create policies for your host as well. And you can even add like Linux machine into your cluster, and you can use policies for them. They won't be able to schedule pods, they'll be part of the cluster. And some extra features with the policies like FQDN domain, egress gateway policies, stage policies I talked about, network set application layer policies. So that's some other features we can use. So to create your policies, you can use the YAML, and if you use the enterprise version, you can use the web UI. Then for your foundations, recommender or build from scratch, it's what I was saying, preparation. So that's where it's the most important. You need to have all your logs and all your required specs on the paper, on the table to create your policies. If you're the one creating the applications, it's quite simple. But if you're another team, like an authoring team, you will ask the dev team to give you all the specs. Or you'll have to test the application yourself and find out. Namespace, policy definition, target, and set rules. It just makes sense, you know, and then you'll have something like that. You've got the name, in what tier, security, order 210, and then you'll get your rule. So now I'm going to talk about the efficiency. That's maybe Captain Obvious, you know, for you. It's just best practices, so it makes sense, it's logical, but it's something you have to keep. Naming convention rules. Try to have a right and good name for your policies, because maybe you'll create policies and it will be another team that will manage them or see them in production. Document and comment your policies. One policy per microservice or endpoint. Like you've seen earlier, you know, with the policies board, you've got your ad service, your email service, and so on. So try to keep it very clear with only one policy per type of microservice. Because if you need to edit it, at least, you know, if you do something wrong, like you do a deny all, it's only one service that will be broken. The tiers and the orders are very important. Like I was saying, if you use a security tier, it might be at the top, the application tier at the bottom, and the order as well. The default deny at the top will break your cluster. If it's at the bottom, it will just ensure the zero trust is in place. So it can be two different stories. We have the global network policy, so you have to use it. So if you're doing a cluster-wide policy, just use that feature. Just you don't have to add your namespaces. It's just perfect. The labels, they are your friends. Use labels as much as you want. So if it's an application called, I don't know, cat, use label cat, and then if it's the front end, use cat, front end, and so on. Build them because there is no zone-based architecture in Kubernetes. So the only way to create your zones is to use the namespaces and to use the labels. So the labels will be like your VLAN, kind of. You can create a front end, or you can create a specific name like trusted, restricted. And then with the labels, you can say restricted can talk to the trusted, and the trusted can only talk to the outside. So that's how you're going to build your zone. It's the labels. And the network set and DNS. DNS, it's pretty obvious. It exists for like 40 years, so we all know why it exists. And the network set is actually interesting. Let's say you have 100 policies that will have 100 of IP addresses that are authorized, like outside of the cluster. If one of the IP is decommissioned and you want to remove it, you'll have to edit 100 policies. If you use a network set, it's kind of an object in Calico with all the IP addresses, and it will have a label. And then you will use this label into your policy. So if you modify the network set, it will modify all the policies instantaneously. So to manage multiple IPs, it's going the must-have. And on top of that, we can use thread feeds. We can use thread feeds. So it means you can use a URL to feed some IP addresses, and then the network set will use the feed to be automatically updated. So what's happening here, we can use like Feodo Tracker, which is a third-party security provider, and they give you the daily malicious IP addresses in a text file. It's like a URL, and you can use that URL into a network set, into a policy. So it means every single day your pods that have access to internet, they will be denied those malicious IPs. So it makes the life easier for you because you won't have to manage hundreds of network policies. Performance, combine multiple rules per policies. So if you have 2-3 rules, don't do 2-3 policies. Just do one policy. It just results in smaller IP tables and rules and faster processing. Because don't forget that the more policies you have and the more CPU your nodes will use to read them. So you still have to be very efficient in the way you create your policies. And also there is another example, is scope your policy correctly. Instead of using a select all, and then in your rules you're going to select the source or destination, just do it straight away into the policy, not into the rules. Use the selector in policy and avoid the selector in the rules. So there is an example here. It's a bad example. It works, but it's a bad example. The selector is all, and then the selector is using a label. And here we have the same policy, but we're going to select the backend first and then the ingress, and we don't care about the destination. So it's a tiny example that this little change over 100 policies and policies with hundreds of rules inside, it can maybe save seconds to refresh all the tables, because you'll have to understand the policy engine will read all the rules and put them into the IP tables, and it will take CPU consumptions and it will take times. So when you start to scale up, we may talk seconds. So that's why Sean is doing after me a best practice for big scale, like 10,000 plus. So he's going to talk about the big stuff. So that was my presentation for today. Just some best practice and consideration when you're building your policies. If you keep to that, you should be good. And it's better to do it now before you scale up, because otherwise it would be a mess to fix everything. So just scan the code and you can just read that later if you want. Thank you.